Hi guys, my name is Victor from University of São Paulo in Brazil, and I will present the paper, a systematic mapping study on the multi-tenant architecture of SaaS systems. First, I will present a brief introduction about the paper. After that, I will discuss the most important issues involved in this research, such as cloud computing, software as a service, and multi-tenant architecture. From this contextualization, I will show the three main phases of the study: planning, conducting, and reporting. Finally, the strategies to cover the threats to validity and some final remarks. It is important to keep in mind the scope of the study. It shows a systematic mapping study on the multi-tenant architecture of SaaS systems. The goal was to identify research topics and opportunities in this domain. 89 primary studies were selected for discussions. The results showed the relevance of multi-tenancy and pointed out the main research trends in this topic for the next years. Cloud computing has emerged from the contribution of parallel programming, distributed computing and visualization, and it has become one of the main research trends by offering a new way to provide the resources on demand via internet. A cloud can be understood as a large pool of virtualized resources which can be dynamically reconfigured to variable scale, and it is exploited by pay-for-use model, like water and electricity companies. The main characteristics of this model are: on-demand self-service. A consumer can use the computing capabilities as needed automatically without requiring human interaction with each services provider. Broad network access. Capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous, thin or thick client platforms. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. Rapid elasticity. Capabilities can be rapidly and elastically provisioned, in some cases automatically. Measured service. Cloud systems automatically control and optimize resource use by leveraging metering capability to the type of service. With the variety of types of resources being offered in the cloud, three main cloud models emerged: infrastructure as a service, platform as a service, and software as a service. The IaaS model is related with providing of network resources and its virtualization. The PaaS model provides a platform to develop and execute an application into a cloud infrastructure. The SaaS model allows to provide an application on demand and to address simultaneously multiple users. It is important to note that the capability provided to the consumer is to use the provider's application on a cloud infrastructure, and the consumer do not need to manage the access, security, availability, and performance. Multi-tenant architecture is vital for SaaS systems, and this characteristic is the main factor that differs from conventional web applications. In general, the multi-tenancy can be understood as a property to address multi-customers simultaneously, so-called tenants, in a transparent manner aiming to reduce costs. Besides that, the tenants can configure the system to their needs. That is, they can apply changes in the systems in terms of interface and business rules. Multi-tenant application is an application where a single running instance serves many customers. Thus, this application can be considered as a polyformic application, where for each tenant a specific application according to its requirements is provided. For this mechanism, it is necessary that application be compiled on runtime and dynamically. Thus, a runtime engine from provider is responsible to compile a variant application to a specific tenant, taking into account some elements: kernel code of SaaS system, tenant-specific metadata, which includes data and customization, common metadata for all tenants, and isolated data for a tenant. This application is executed on shared pool of hardware and software resources, taking into account the context of a multi-tenant architecture of SaaS systems and the need to investigate the opportunities in this domain. We performed a systematic mapping study. This study was conducted considering three main phases: planning, conducting, and reporting, following the Hans guidelines. In the planning phase, it was defined a review protocol containing research questions, search strategy, inclusion and exclusion criteria, and methodology for data extraction. Two research questions were defined. First question: what research topics related to multi-tenant architecture can be found on the current literature? Second question: what are the main research challenges and opportunities related to the development, testing, and evolving of multi-tenant SaaS applications? Search string and the electronic databases were also defined. The search string was elaborated and refined according to an initial set of key papers selected and based on citations of these papers. We defined the search string considering the following keywords: cloud, SaaS, and multi-tenancy, their frequent variations, and Boolean operations. Relevant primary studies were selected based on the following inclusions and exclusion criteria. Not all inclusion criteria should be satisfied for each primary study. ICA is the only mandatory criterion for the inclusions of papers. We have used a data extraction form to answer the review questions. In the conducting phase, the primary studies were identified in the databases. Scopus returned a large set of studies, 638. IAAA, HCM, Vili returned 168, 594, and 25 respectively. This figure shows the distribution of papers retrieved in each search database and after applying the inclusion and exclusion criteria in the reading process. From the initial set, 135 duplicated studies were identified and removed. In the selection phase, based on the partial reading, titles, and abstracts, a set of 149 papers were selected according to the inclusion and exclusion criteria. After the full reading, only 89 papers were selected. In order to validate the inclusion and exclusion criteria application, each primary study was scored by reviewers in both partial, title and abstract, and full readings. A score 0 means rejected, and 1 accepted. In case of doubt, the reviewer scored the paper with 0.5, and the other reviewers were asked about its relevance so that a consensus could be reached through the adoption of score 0 or 1. The scoring process was conducted in a sequential and independent way, that is, one reviewer read and scored each paper without interference from others. This figure below presents the disposal of the papers selected from workshops, journals, and conferences. Conferences have a dominant position with 63 papers, 70.8%, followed by journals with 18 papers, 20.2%, and workshops, 8 papers, 9%. It can indicate that workshops still have to be formed and researchers submit their results to conferences and journals with a larger scope. In order to clarify the focus of the selected studies in quantitative terms, we have defined some categories according to the paper domain to answer the first research question. This figure shows a mapping containing number of primary studies distributed according to publication year and category, which one paper can be classified in more than one category. Security, testing activity, and experiments may be considered important issues to quality assurance, and therefore these issues are into quality assurance category. architectures, frameworks, requirements, and variability management, and migration from web conventional applications to multi-tenant SaaS applications are mentioned in the current multi-tenancy literature as important issues to address in future research. For instance, Walraven et al. Presented an alternative based on product lines and the coexistence of specific settings for tenants to facilitate the requirements management. Truyen et al. Evaluated the context-oriented programming for such applications aiming to improve their development process. The main idea was to enable the customization of specific requirements for each tenant, providing positive results in terms of development effort. Sengupta and Roy Chaudhry showed a guide to implementing new tenants without impacting those already deployed. Multi-tenant architecture has introduced new challenges related to load balancing and resource allocation, including the requests on the tenant level, service level agreement, performance objectives, and quality of services. Sun et al. Proposed a suitable load balancing policy for a multi-tenant environment to provide satisfactory quality of services. A considerable number of papers have addressed applications customization. For example, the customization of a complex application in an error-prone task. It requires high manual efforts, and the users may not know the best choice in terms of customization. Thus, the authors perform a study of the possibilities available for the customization of a sales application, and a semi-automatic customization process was created to reduce efforts. Quality assurance is a promising research topic in multi-tenant architecture that includes testing strategies, metrics, and quality criteria, and alternatives related to security. For Tsai et al., one of the main challenges in the testing activity of multi-tenant SaaS application is to deal with the large set of composition possibilities and interactions among components. They provided a combinatorial testing approach to generate dynamic test sequences and achieve a high structural coverage. 19 selected papers have cited database-related issues as a promising research direction. Yayish et al. Discussed an access control model based on a database schema. They also proposed an access control algorithm that enables users to access the data granted based on users' groups or assigned roles. Although most studies have addressed the development of multi-tenant SaaS applications, standards are scattered and do not often follow a methodical approach. Metrics are used to guide managers during the software quality evaluation. Despite many studies mentioning their importance, there is still a lack of quality metrics for this context. Organizations and academia provide security testing, recovery testing, fault tolerance testing, or some alternative to cover the complexity of multi-tenancy for SaaS. But there is a lack of standards to drive the development of interoperable test tools. Despite the on-demand software validation in the cloud environment, most of the regression test studies have focused on retest a version in a previous configured test environment. However, validation methods must be dynamic to deal with multi-tenancy. There is a lack of guidelines about which testing techniques and criteria to use considering the testing objectives in context of SaaS systems. Consolidated process to guide the migration from web conventional of multi-tenant SaaS model can contribute with the adoption of this model for applications where only the multi-user model is not enough. In order to ensure an unbiased selection process, research questions were defined and exclusion and inclusion criteria were specified for the obtaining of relevant studies. Although many sources were used for the selection of primary studies, some might have been neglected. We try to reduce this threat by selecting sources that index studies from the main scientific sources in cloud computing and covering most of the relevant papers. All reviewers that participated in this study work on cloud computing. The protocol was assessed by specialists so that deviations during the analysis could be avoided. It is worth mentioning that not all information was obvious to answer the research questions. Several sources, as external papers and technical reports, were consulted, so that validity of the process could be ensured. Many studies has been conducted in the multi-tenancy context. Most of select primary studies is recent. 89 primary studies were selected for discussions. We have defined 2 research questions that reflect the scope of the study and 5 categories to map the contributions and challenges. This mapping study also points out the need for experimental studies evaluating the proposed approaches and a systematic test strategies, extending different techniques to increase the quality of these applications. Thank you all for your attention.